Let's have a look at the HDK server application. It looks similar to the other one when you first start up. You click accept on the disclaimer. This time there's no requirement to specify any credentials. This is something that runs solely on your machine and doesn't have to go through the gateway. Normally you would see just a single entry when you first load this application. This is a dummy entry, and it's just there as a reference point so you can see the sorts of resources you might be interested in adding in. The primary use of this application is to provide simulation of existing or of planned resources. And so I don't know if you've looked at the client app videos yet, but you probably would have noticed this particular reference in the list of available resource devices. What I've done in this case is I've added in a simulated temperature sensor, and we'll talk about that a little bit more in a minute. Also on this in this application, there's some diagnostics. If you want to look at the what you've already done some testing with, there's a debug log that you can open up, and you'll see a combination of things in here. The HDLC is the protocol used over the UART attached to the millinic, and if you're looking through here, you're going to see some handshaking occurring, but also some requests for other CoAP resources. I can't really see anything here at the moment. When we go into adding a resource and then doing actual simulation, we'll go back in here and have a look at the interaction between the client and additional resources demonstrated here. Now, of course, you can clear it and can change the rollover amount on the debug log. Right now, we're limited to 100,000 lines. Once you hit that threshold, it just starts over again. But you can change that to whatever you like. And of course, you can clear the debug log if you think you've already got more information there than you need, and you're just looking to trap something specific, perhaps for support or to demonstrate some results to your peers. Now, let's talk about that temperature simulation a little bit. Notice here that the resource that we added is something called temp, and here's the path where I generated that simulation. And if you want to make sure that DLL is still valid, just click on the Diagnose button. That DLL is loaded and its various entry points are validated, and then you see the results of the diagnostics there. The only tool available at this point in time is that to create an empty simulation, and all you do is put a name in here and then specify a target location. In my case, I had created a directory called Simulations. I'm going to select that and just create one called For Demo. And now you've got a simulation. At some point we need to attach that to a target device. The way we do that here is by editing the device itself, and we're going to add a resource. Gives you a dummy path to start with. I'm going to change that to demo just to match it up, and we'll go back to simulators. Oh, my apologies. I haven't built this yet. Why don't we just build while we're in the neighborhood? I'm going to open up Visual Studio. There are references in the Dev portal as to where you can get a free version of Visual Studio. I'm going to open a project, go back to our simulations, go to For Demo, open up that project. And there it is. This is a C++ application. And I'm going to open up the source files here. And so this is the primary template for the simulations. All it really does is show all the entry points that are required. So this is our main entry point. This is what the server application looks for when it starts the operations. State change currently isn't implemented, but will be used for processing observe support. And this just proves that we've finished our initialization. When you load Windows DLLs, it does some initialization in DLL main, and we just want to confirm that we got all the way through DLL main and nothing went to bump in the meantime. That's part of what's being shown when you run the simulation. So let's build this. And then poof, they're compiled. I should also have shown you this entry point, process CoAP requests. So as requests that aren't handled by the MILI-NIC that you're processing, then the MILI will then call pass the CoAP request through to the either the simulator or whatever else is attached to that MILI-NIC. Input is a CoAP request, and then we process various things and produce a response back. In this case, all that's supported is the get, and all I'm returning back is an ASCII string saying this is the get payload, and that's all you're going to get in this case. It's going to be up to you to add in, how you're going to manage the handling of puts, etc., etc. So I might change this for that temp simulator so that you can return back Celsius or Fahrenheit, for example. If we're doing something that's eventually going to become a real-world application, then there might be other things you want to simulate. So let's go back to the application real quick. We're going to add a resource here. Here's the DLL. Content type we're stating is 42, but that's not really true, is it? You could add other link attributes, for example, for the temperature simulation, we added in the number of degrees, or how the response is going to be returned, that i.e. that it was degrees. In this case, we'll just leave it as that. It's just going to be ASCII response. And there it is. There's your simulation set up for this particular device. I'm going to save and close all the updates, and lo and behold, there it is there at the bottom of our list. Going back to Diagnostics, if you select that device again, you can see that now we've got that for demo simulation. If you click Diagnose, poof, there it is. And that's it for simulations for the moment. At some point, I'll also demonstrate exactly how to set up the cable on the board so that we'll do some real listening to the example. We've already talked about tools and diagnostics. So that's it for this segment.